Table 1 shows length in centimeters of 230 cables used in an electric workshop. So you've been given the length in centimeters from 70 to 80, 80 to 90, 90 to 100, up to 140 to 150. Then the frequencies, the number of cables in each and every class has been given there. Then you've been told to use an assumed mean of 105. Hence, to determine the mean, mode, and standard deviation. So for us to establish the concept of an assumed mean, first of all, we need the classes and the midpoint. So the midpoints will be the variable. Then we create a new variable using the assumed mean of 105, isn't it? So we start by having our classes. So the first class is from 72. So the classes are given to be the length in centimeters, isn't it? So the first class from 70 to 80, the next class, 80 to 90, the next class, 90 to 100, the next class, 100, 110, the next class, 110 to 120, the next class, 120 to 130, the next class, 130 to 140, the next class, 140 to 150. So from the classes, we've also been given the frequencies, the number in each and every class, isn't it? So the first frequency we've been given is 12, then 18, then 35, then 42, then 50, then 45, then 20, then 8. So we now get the midpoint, the one representing each and every class, isn't it? So the midpoint we can denote with the variable x. So what is the midpoint of between 70 and 80? The average of 70 and 80 is 75, isn't it? The midpoint of 80 to 90, average is 85, isn't it? Then the midpoint of 90 to 100, average is 95. The midpoint of 100 to 110, average there is 105. Midpoint of 110 to 120, average there is 115. The midpoint of 120 to 130 is 125. The midpoint of 130 to 140, average there is 130. The midpoint of 140 to 150 is 145. Because we want to use an assumed mean, then we need a new variable. So we told the assumed mean to be 105. So we need a new variable d. So our new variable d is going to be the current variable x minus the assumed, isn't it? Yes. So the new variable d is x minus assumed. So from here, you will now have d is x minus assumed. So if you put a bar on top of d, you put a bar on top of x, isn't it? Meaning d bar is going to be x bar minus the mean of 105. Because the mean of 105 is just the same 105, isn't it? So d bar will be x bar minus 105. So for you to get the mean of x bar, you make it the subject of the formula, isn't it? So the mean x bar, if you make it the subject of the formula, you get x bar will be negative 105 going the other side, plus 105. So you have d bar plus 105. Now from there, we now have, we get our d values. It is x minus the assumed, isn't it? So put the column of d and get the d values. So the first d, x minus d, 75 minus 105, negative 30. The next d, 85 minus 105, 85 minus 105, negative 20. Then next, 95 minus 105, negative 10. 105 minus 105, 115 minus 105. Calculate that. 10. Then the next x, 120 minus 105. 20. Then the next 130 minus 105. 30. Then the next 145 minus 105. 140, isn't it? 40. Good. So 145 minus 105 is 40. So from there, we now have the b values is now what we want to use to get the mean, isn't it? So from there you start. When you sum up all the f values, you get n, because n is the summation f. When you sum all the frequencies, you get the total number, and the total number was 230. Meaning, if you add up all the frequencies, you are supposed to get the total number 230. Confirm that. If you add up all the frequencies, you get the total number 230. After that, you now start with the first thing you are looking for there, the mean, isn't it? Yes. So the mean, we are looking for the mean of d, because d is the value which we are working on from the assumed mean, isn't it? Then after getting the mean of d, we can now get our mean of x, which will be mean of d plus the assumed, isn't it? So what will be the mean of d? So the mean of d will be denoted by d bar, isn't it? So the mean of d bar is the expected value of d, isn't it? Meaning you sum up all d values and you divide by that total number, isn't it? So you sum up all d values, and when you are summing d values, you sum them with the number of times they are appearing. Because this d value, some of them, like this d value is appearing 12 times, isn't it? So when you are adding it, you add it up 12 times, isn't it? This d value is appearing 80 times. So you are summing up all the d values and the number of times they appear, then you divide by that total number, then you have found their mean, isn't it? Are we together? Yes. So from there, it means you already know n is 230, the sum of all frequencies, isn't it? Yes. So we need the column of fd, then we sum, isn't it? Yes. So create a column of fd. Create a column of fd. So in the column of fd, it means f times b, isn't it? Yes. So start. F there is 12, b there is negative 30. 12 times negative 30? Negative 360. Yes. Go on. 18 times negative 20? Negative 360. Negative 360. Yes. Go again. 35 times negative 10? Negative 350. Negative 350? Yes. 42 times 0? Is 0. 50 times 10? 500. 45 times 20? 900. 20 times 30? 600. 8 times 40? 320. So after that, we need to sum all FDs, isn't it? So if you sum up all FDs, the FDs, what do you get? Negative 360 minus negative 3, minus 360 minus 350 plus 0 plus 500 plus 900 plus 600 plus 320. If you add them up, what do you get? 1,250. Everybody has found that same value. If you add on this, you found 1,250. So here, what we now do is we just substitute the values, isn't it? Yes. Summation of FD we found is 1,250. Then n, their total number was 230. So in the end, what do you get to be the mean of D? 1250 divided by 230, you have 5.43. So we found the mean of D. But we are using the mean of D to get the mean of x, because x is the mean of the values there, the lengths, isn't it? So what is the mean of x as we demonstrated there? X is the mean of x. X, when we make it the subject, it was the mean of D plus the assumed mean, isn't it? Yes. Are we together? Yes. So the mean of x is the mean of D plus the assumed mean 105. So what do you get with the mean of x? Mean of D is 5.43 plus, assume to be 105 to get the mean of x to be 110.43. 110.43. So we found the mean. We found the mean to be 110.43. Are we together there? Having found the mean, the next thing we are looking for is that the mode. Then the mode. So how do we get the mode? How do we get the mode? So what is the formula of getting the mode? So the mode is the lower class limit of the model class plus D1 over D1 plus D2 into the class intervals, isn't it?
Yes.
Meaning for us to determine the mode, we need to know the model class, isn't it?
Yes.
The model class is the class with the highest frequency. So the class with the highest frequency, we check the frequency, what is the highest frequency? 50 is the highest frequency, isn't it?
Yes.
So if 50 is the highest frequency, this is the model
Class.
The model class. So the model class will come and record it there is 110 to 120, isn't it? Now from this class you get its limits, isn't it? So this class ended at 110 and this one started at 110, meaning the average there is 110. You want the lower class limit, isn't it?
Yes.
Then this other model class ended at 120 and this class started at 120, meaning the average there is 120 plus 120 divided by 2, isn't it? So the upper class limit is 120. So in this case, the class limits were the same as the class boundaries, isn't it? So from the class limits is where you get the class interval or the class weights, isn't it? So the class interval is the upper class limit minus the lower class limit. So 120 minus 110, class interval is 10, isn't it? Then we need the D's, isn't it? So if here is the model class, D1 is the one in between on top and D2 is the one in between below, isn't it?
Yes.
So D1 will be the frequency of the model class minus the frequency above it, isn't it?
Yes.
So D1 is 50 minus 42. You get it to be 8. Then the D2 is here, the one that down below. It is the frequency of the model class minus the frequency of the class below it. That is 50 minus 45. You get it to be 5, isn't it?
Yes.
Then we now want D1 plus D2. That is 8 plus 5. You get 13. So having found everything, we now substitute in the formula of the mode, isn't it?
Yes.
So what is the mode? The mode is the lower class limit of the model class. And the lower class limit we found to be 110. Then it is class D1. And D1 we found to be 8. Then it is over D1 plus D2. D1 plus D2 we found is 13. Then it is times the class interval. And the class interval we found to be 10. So in the end, what do you get to be the mode? 110 plus 8 over 13 times 10. What do you get to be the mode? What are that?
16.15.
116.154. Just 15 is enough to place more places, isn't it?
Yes.
So we found the mode is 116.1.15. So 116.15. Now after getting the mode, they want us to get the standard deviation. And we know the standard deviation is the square root of the variance, isn't it?
Yes.
Yes. And what did we see the relationship between the variance of x and the variance of d if d is x minus assume the variance of x was the same as the variance of d. That is what we proved, isn't it?
Yes.
The variance of x was the same as the variance of d. So it means the moment you are using the variance of d to get the variance of x, we are using the variance of d to get the variance of x. So we proved that when we prove that when b is equal to x minus assume, then we found that the variance of d was the same as the variance of x, isn't it? Are we together? Yes. So it means by the moment we find the variance of b, then that will be the variance of x, isn't it? Because we are using the b's for the assumed mean, isn't it? We don't get the variance of x directly, we don't use the assumed mean, and the assumed mean is using the b values, isn't it? So what did we say is the variance? So in this case, when we want the variance of b, we said the variance was the mean of b squared minus the mean squared, isn't it? You see the mean of b squared, that means it is b squared, the mean of b squared is on top, isn't it? Minus the mean squared. So this one you can see is the same as the expected value of d squared, isn't it? Minus the expected value of d, then squared, because the expected value is the mean of d, isn't it? So this is the mean of d squared. But this one is the expected value of d squared, which is the mean of d squared. So what do we get here when we expand? The expected value of d squared is the mean of d squared, isn't it? And the mean of d squared means you are summing up all the d squares and the number of times they appear, isn't it? Over their total number. That is how we get the expected value of d squared. Meaning you are looking for the mean of d squared, isn't it? Yes. So the mean of d squared, it means you sum up all the d squares and you divide by their total number. At the moment you are summing up all the d squared, you must multiply them with the number of times they appear, isn't it? Then it is minus expected value is the mean of d, and that mean of d has been squared, isn't it? And already we found the mean of d to be, we found the mean of d previously to be 4 point. We found the mean of d to be 4 point something. 4.5?
5 point.
It was 5 point. 5 point?
43.
5.43. We've already found the mean of d. Meaning we have this value and we know it's 2 times. So what we are needing is the sum of fd squared, isn't it?
Yes.
So it means for us to sum all the fd squares, we need a column of fd, a column of fd squared, isn't it? Yes. So in the column of fd squared, you start fd squared, meaning it is fd times d, isn't it?
Yes.
Fd times d, you get fd squared. So fd times d, negative 30 times negative 360. It is just 30 times 360. Negative times negative is positive, isn't it? You have?
10,000.
10,000?
800.
800. Then the next one, negative 20 times negative 360.
7,200.
7,200. Negative 10 times negative 350. 3,500. 0 times 0 is 0. 10 times 500. 5,000. Gone. 20 times 900, 18,000. 30 times 600, 18,000. Then 40 times 320, 800, isn't it? So we found all the fd squared. Fd times d give us the fd squared. So when we add up all the fd squares, what do we get? When you add up all fd square, what do we have? Summing up all the fd square, we have 75,300, isn't it? Now we have everything, we now substitute, isn't it? So, summation of fd squared we found is 75,300, and the total number was the summation f, which we found was 230, then minus the mean of d squared, and the mean of d we found was 5.43, then it is squared, isn't it? So if you work out this, what do you get to be the variance of d? What do you get to be the variance of d? 75,300 divided by 230 minus 5.43 square. What do we have to be the variance of d? 297.91. So you've seen when B is x minus C, then the variance of B was the same as the variance of x, isn't it? So it means this variance of B is the variance of what? That variance of B is the variance of? Is the variance of x. So from the variance, we can now get the standard deviation. So standard deviation, you know, is the square root of the square root of the variance. So standard deviation is the square root of the variance, which you get to be 17.26. So we have worked out everything as expected using the assumed mean approach. Okay? That is how to handle a case like that. Let us see another case when you have unknowns